This next unit is going to be solving equations. And we're going to start with one-step equations. And I know what you're going to tell me. I can solve it in my head. Well, you better be able to solve it in your head because these are some pretty basic problems. But as we get further along into equations, you're not going to be able to solve it in your head anymore. So you have to know the strategies starting with those basic problems. So just to be clear, I'm not testing, can you find the answer? What I'm testing is, do you know the process? So if you do not show me the process, you will not get full credit. I don't care if you can do it in your head. I'm not checking for the solution on these. I'm checking if you understand the process. When we get to problems that look like this, 3m plus 5m minus 17 minus 2m equals 327. Can you tell me right now what m equals? Quickly, quickly. You can't. So that's why you need to know the process. By the time we get to a problem that looks like this will be super easy as long as you follow the steps. So here are the steps when we're solving equations. We have to follow inverse operation. Basically, what we're trying to do is, on every problem, we're trying to get the variable by itself. We have to figure out, what does m equal? What number can we put in there to make this equation true? So 3 plus some number is going to equal 10. Can you tell me the answer right now? Well, I would hope so. 3 plus 7 is going to equal 10. I know you can figure out the answer, but remember, what am I checking? I'm checking to make sure you know the work. So when we're solving equations, think of the equation as basically a scale, like you see in the science class. What we have on one side of that scale has to be the same exact thing as we have on the other side of the scale in order to stay balanced. Well, this equal sign is telling us already this over here is the same as this over here. It's already balanced. And the center of our scale is always the equal sign. So I'm going to draw a dashed line down through that equal sign. The equal sign is always the center of the equation. So now what we have to do is we have to get the variable by itself. Well, on the same side as the m, remember this is our left side of the line, and this is our right side. Does that 10 have anything to do with m right now? No, it's on the right side. But on the left side next to that m is a positive 3. So we're going to have to get rid of the positive 3. Well, according to inverse operations, addition is the opposite of subtraction because they cancel each other out. And multiplication is the opposite of division. We'll get to that a little later. Right here we have an addition problem. We have a positive 3 that we need to get rid of. Well, to get rid of an adding positive 3, we just have to subtract 3. So I'm going to put that underneath my plus 3. But what I do to the left side of an equation, in order to stay balanced, I have to do the same exact thing to the other side. So can I put it right here? No, because those are both on the left side of the line. So if I put this minus 3 on the left side of the line, I have to put the same exact thing on the right side of the line. I should be able to draw a line straight across, and your inverse operation is on the same exact level. Now let's work this problem out. Well, 3 minus 3 is 0. So now I can cross that out. The only reason I'm allowed to cross that out is because it makes 0, and 0 is the same as nothing. But right here, I still have that m. On the line, all the way down, every single step, the line is always where I should see the equal sign. And now over here, 10 minus 3 is 7. I agree, that's what we did in our head. That's the same exact answer. But remember, I'm not checking to see if you can just find the answer. I'm checking to see if you can do the work. because as we move on, you better know your steps. So let's move on to number 2. Now they're trying to ask what number can be subtracted by 5 and you get 2. Well, actually, this answer should also be 7. If I just put 7 minus 5 equals 2, I'm telling you right now, that's not the work I'm looking for. Because that means you just did it in your head and showed me that it worked. I'm not looking, can you do it in your head? I'm looking, can you do the math to find the answer? So the first step I want to see is draw that line down through that equal sign. Yes, I want to see the line so you can clearly see the left side and the right side. On the left side, we have our x with a minus 5. But remember, we need that x to be by itself. So I can't have that minus 5. Well, how do we get rid of a minus 5? Well, remember, the opposite or inverse of subtraction is addition. So under that negative, I'm going to put a positive because different sign, subtract. And in order to get rid of a negative 5, I need a positive 5. So when I draw my line straight across on the same level, I need to do the same exact thing to the other side to keep it balanced. So if I add 5 on the left, I have to add 5 on the right. So right here, negative 5 and a positive 5. This is a negative, this is a positive. Different sign, subtract. 5 minus 5 gets me 0. So I still have the x on the left side. And on my line, what always goes there? That's right, bring down the equal sign. And 2 plus 5, that's how we get 7. So remember, I'm not checking to see if you can come up with the answer. I have to see the inverse operation in order to show the work. Now let's get to some multiply and divide. So these are still one-step equations because it only takes one inverse operation to solve. But we don't have any more addition or subtraction. We have multiplying and dividing. So let's look at this problem right here. My variable, remember that's always the letter, is the y. And I need to get that y by itself. So if 6 is touching the y, remember touching means multiply. Well, if I have multiply, to get rid of it, I have to use the inverse operation. And the inverse operation of multiply is divide. So to get rid of a multiply, I have to divide. And remember, we're not in elementary school anymore, so no more of that little sign. Divide, now that we're in algebra, is a fraction bar. But if I put a fraction bar on the left side, I also have to put that fraction bar on the right side. And what number am I trying to get rid of? Well, the 18 has nothing to do with the y. The 6 does. So the 6 is what I need to get rid of. So I'm going to put a 6 on the bottom of that fraction. But if I divide by 6 on the left side, I also have to divide by 6 on the right side. So now, when I have the same number on the top and the bottom, remember 6 divided by 6 is really just 1. So I have 1y. Well, 1y means I just have a y. And over here, 18 divided by 6 is 3. Remember, I know 6 times 3 is 18, but you have to show me that inverse operation in order to get credit. So what happens when we move on here? Most common mistake I see is people see a negative 8, so they want to add 8 to both sides. That's actually not what we're doing right here, because the m is not subtracting 8. It's actually touching. So that's not a minus 8. In this case, that minus really just means negative. Negative 8 is touching the m. So I could put a dot right there because negative 8 is multiplying m. And remember, to get rid of multiply, we have to divide. And what we do to one side, we have to do to the other. So most people would divide by 8 on both sides, which cancels out that 8, but that m is still not by itself because what's that little guy out there? We can't have the negative. So in order to cancel an 8 on the top, I needed an 8 on the bottom. The same thing applies to a negative. When I have a negative on the top of the fraction, I have to have a negative on the bottom of the fraction, so that can also cancel out. But if I put a negative 8 on the left side, I have to put a negative 8 on the right side. So now I have that m all by itself. On my line I put my equals. And now I'm dividing 32 divided by negative 8, which actually gets me an answer of negative 4. Remember, one negative always wins when we're dividing. This last one is the tricky one. People see a 3 on the bottom of the fraction, so they try to put a 3 on the bottom of this fraction. But that 3 was already there. I need to get rid of that 3 so this d can be by itself. Well, when I have a 3 on the bottom of a fraction, the only way I can cross it off is like this, when we have the same number on the top and the bottom. So if I'm dividing by 3, the opposite of dividing is multiplying. So to get rid of a 3 on the bottom, I actually have to put a 3 on the top. And since I put the 3 on the top on the left side, I have to put the 3 on the top on the right side. Nothing is on the bottom. So those 3's can cancel out, and I still have a d on the left side. And 9 times 3, I get 27. To plug it back in, I could say 27 divided by 3 gets me that 9. Don't forget, I'm not just checking answers. You better show the inverse operation to solve all of the equations.